So once we have our information here, what we want to do is we want to basically apply some ideas to this. Like, if you know how high this thing is, as a function of time, um, one good piece of information that you would want is the velocity. How fast is this thing moving? The speed, essentially, right? But the deal is, for the velocity, one of the things that you can do is this. Um, let's move this out so I can kind of see my face. There we go. All right. So to get the velocity, what you would do is, how do we get the velocity by looking at this data? Do you know? Off the top of your head, I was just wondering. If no, that's fine. All right. Change the times. Close, close, close. I think that you're kind of onto something. Um, Here's what you're doing, okay? The velocity is a measure of the change in distance, and in our case it's elevation, over the change in time. As the distance changes, you want to figure out how far it went divided by how long it took. Right? When you drive, you go 50 miles per hour. It's a change in distance, miles divided by 1 hour change in time. We cool? So in order to figure that out for this one, it would be all right. If this is our graph, then that's what we do is um, let's look at two data points, and these two data points includes the four cells, because these two data points correspond to actually two spots on our chart. It corresponds to this part right here and that part right there. See, the point 0, comma 1118, and the point 586, comma 4511. There we go. 0, 118, or 1, 118, and 586 and 4511. Cool? See, this is the actual application of what you're learning in math class, which I think is really cool. Because what you were learning in math class is how to figure out the slope of a line and all that kind of stuff. Well, this is what we're doing. This is what you do with it. All right, so what I want to do is I want to figure out what the velocity is. And the way I can do that is I can say, okay, I want this cell to be equal to the one right here. I want this to equal to, I want you to computer, I would like for you to calculate the change in height. So it would be this number minus that number. So I'm going to put a parentheses, this minus that, divided by the change in time, which would be that minus that. So I'm going to put another parentheses, that minus that. Are we cool? And what I'm going to do is I'm going to label that velocity, and the units are meters per second. Now, what you could do, my friend, is you could do this by hand, and it would be a big pain in the butt. You would just kind of say, okay, it would be this minus that divided by that minus that, and essentially it would not be that fun to do because it just take you a long time. Luckily for us, luckily for the world, is computers are really good at doing dumb things. And I'm not saying that this is a dumb thing, but I mean, computers are really good at doing mundane tasks. And this is kind of a mundane task. So what you can do is you can go like this. Move your cursor to the bottom right-hand side of the screen, or of the cell that you want, and click, you'll see a little plus sign up here. Click on that, and what happens is you drag it down. This, this, oops. This thing will actually apply that same formula to all the cells next to it. See how if I click anywhere on here, see how it applies it to these four cells right next to it? So this is the velocity at any given time. Okay, now what we call this in math is we call this the instantaneous velocity. This is the velocity that the balloon is moving at that exact second. Now, technically, this isn't the instantaneous velocity, but The instantaneous velocity is like the velocity you're moving over a very, very short time interval. And so that's why we have, I mean, you change velocity. When you drive a car, when your mom drives to work, maybe, or your dad drives to work in town, they don't go 55 miles per hour the entire time. Sometimes they're going 0 miles per hour. Sometimes they're going 30 miles per hour. Sometimes they're going 50 miles per hour. Sometimes they're going 65 miles per hour. If they're speeding, they're going 85 miles per hour. So they're changing the velocity. So the the velocity that you're moving at that exact given point in time, that is your instantaneous velocity. Does that kind of make sense? Yes. So my question to you is, if you look at this thing, at what time is the balloon going its fastest instantaneous velocity? To see how it changes. It changes over time. Cool? Yep, you saw 6 there. Now, here's the thing. I want you to do it for yourself. So I'm not actually going to show you all of the data. I'm just kind of showing you how to do this. But I'm recording these videos so you can kind of see, oh, this is how you do it. This will really help me out. All right. Then we will move on to the next thing.